In this video clip, I will show you how to perform meta-analysis in RevMan Review Manager software for data taken from research studies that the outcome is binary. Binary outcomes have levels in it or two categories, and the outcome is estimated by using an estimate of the effect size, which is the risk ratio, abbreviated as RR. In the RevMan, click on the new here. A new window will appear for wizard for new review. Click on next. Then in the next section, choose the intervention review. Click on next. Give the new review wizard title. Let's call it meta-analysis for lung cancer LC. Click on next. Choose the full review for the wizard, then click on finish. An output is generated here in this section for studies and references. Click on it, then click on the references to studies and right click to add studies. In the new wizard window, select the included study, then next, then start entering the author name or the label for the study. Here I'm going to insert 4 different studies and I will give them a name of study number 2016. Then click on next and then next. Then select add another study in the same section, as we are going to add more studies here. Click on continue, then type the study number 2, which is 2019. Click on next, then next, and select the last option and click on continue. Insert the third study 2022, and then click on next, then next. Select the last options, and for the final study, it is 2023. Click on next, then next, and here once all the studies has been inserted, click on finish, and as shown here, those studies are inserted here: 2016, 19, 22, and 23. Click on the data analysis and then right click to add a comparison. Give the wizard a name here. Let's call it MA for LC using risk ratio, and click on next. Select the outcome. Add an outcome under the new comparison. Click on continue. Click on dichotomous outcomes, as the outcome is dichotomous, 2 categories in it. Let's give it a name, MALCRR again, and then next. In this window here, there are several options to choose from. Analysis model, whether fixed effect or random effects, and I will stick to the fixed one. The statistical method is Mantel-Haenszel method, and for the effect size or effect measure, going to select the risk ratio. Click on next. In the next section here, select the 95% confidence interval, which is a standard. I will go for either 90, 95 or 99. Stick with 95%. And for the each study and for the pooled overall estimate for confident interval for 95% for the effect size, which is the risk ratio. Click on next here. From these options, you could select to sort out the output, either study ID or effect size or year of study. We'll stick with the study ID. Click on next, then click on finish. An outlay is generated here for inserting the data extracted from the literature, as shown here. a section for the study or the subgroup, the experimental group, which will be a value added for events and the total number or sample size, and for the control, events and sample size. Weight will be generated here and calculated. The risk ratio, the effect size that will be given here and calculated is the RR using the MH statistical method. Fixed effect models will be chosen here with a 95% confidence interval. To start adding the studies, click on this icon here and then select all the 4 studies and then click on finish, and all the 4 studies are added here in this output, and there is options to start adding the values for the events for each study. There are several ways to do it. One of the way is to click on and select the study and then click on the calculator. In the calculator section here, there are a section to fill the events for the experimental and the control and the total number for the experimental and the control. I'm going to deselect the odds ratio as I don't want the odds ratio, and I'm going to select the show risk ratio calculation. And here as shown, it will produce and generate the log risk ratio and the risk ratio and the 95% confidence interval with the upper and lower limits for the CI. To start entering the data for the first study, for the event in the experimental, it's 12 out of 30, and for the control it is 3 out of 35. And if I hit enter, all the values are calculated here automatically, and the log RR is calculated and the risk ratio is calculated. If I click on update data table, the values are inserted in this area. To add the values for the second study, select the study, click on the calculator, and then add the values for the experimental and the control event and the total number. For the events, for experimental, it is 19 out of 40, and for the control 7 out of 55. If I hit enter and then click on update data table, the values are entered here. For the third one, I could also manually enter the values in this section. 36 for the third study out of 74, 74, and for the control it is 11 out of 61, and for the last study it is 23 out of 42, and for the control 10 out of 51. As shown here, the data now is entered for all the 4 studies with the event in the experimental and the control. Section here is given for the weight is calculated for each individual study with the risk ratio based on MH and a fixed model with 95% confidence interval. And here the section is given for the pooled overall effect size estimate, which is the risk ratio. And in this section is calculation for homogeneity test and for significance of the overall finding. There is an option to change the model, either to go for random or fixed effects model. We stick with the fixed one. If I click on the icon here, a forest plot will be generated as shown in this forest plot. This section shows the study name and labels for the 4 studies, the events for the experimental, and the total number for the experimental, the events in the control with the total number for the control. Weight is calculated for each individual study, and other values are also calculated for the risk ratio for the first study, second and the third and the fourth, and a 95% confidence interval is given here in 2 brackets. based on a fixed effects model and MH statistical procedure. On the right hand section here is the forest plot with the scale at the bottom. The vertical line represents the line of no effect. The bluish square here with different size represent the risk ratio for each individual study, and the size of the square represent the sample size. The horizontal line is the line for the 95% confidence interval, and the diamond shaped symbol here represent the pooled effect size, or pooled RR, which is calculated here to be 3.11 with a 95% confidence interval. The significance of this finding is given here as the p-value is less than 0.05, and the homogeneity test is performed for the 4 studies to search for and examine and test and assess whether there is a variation between the 4 studies. The I-squared is 0 and the p-value greater than 0.05. So this is the way to perform meta-analysis and determine the overall risk ratio, which is a binary outcome for data extracted from literature in a RevMan. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovi, Statistics, GraphPad Prism, G-Power, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovi, Statistics, GraphPad Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.